Okay, so today we'll go over some equilibrium constant problems, and all these problems that I'm doing are available in the link that's in the description. It'll have all these practice problems you can go over by yourself or just follow along with what I'm doing. Okay, so if we want to find the expression for k, first thing we need to do in all of these is make sure we have a balanced equation. So let's go ahead and balance it first. And we count up everything, make sure it matches up, and in this case it does. So we're ready to move on. So when we're finding k just asks us for what's the concentration of the products over the reactants. So in this case, products are NH3, and then remember the exponent that we put on NH3 is just the number that's in front of the compound. So in this case we have a 2, so we square NH3, and then we add our reactants to the denominator. And we have a 3 in front of H3, so we have to cube it. Okay, so that's going to be our expression for K. So now that we have that, we can answer the next question. It's going to ask us for the concentration of H given the three other things that we need to solve for it. So the first thing you want to do is you want to solve for it algebraically. Don't plug in numbers yet. It gets kind of confusing if you do that. Easy to make mistakes. So let's solve for H2. And then since H2 is cubed, we'll take the cube root of it. And now we can plug in our numbers. Take the cube root of all that. And we get 7.87 molar. But since we have two significant figures here, we need to make sure that our answer is in two significant figures. So let's round up. That's 7.97. So our answer should be 8.0 molar. So as always, balance the equation first, find your K, solve for it algebraically, don't plug in numbers until the end, and then make sure your significant figures match up. Okay, the next problem we can do is we want to find the expression for this reaction. So we can start it the exact same way we did before, checking to see if it's balanced. In this case it already is balanced for us, so we don't need to do anything there. So we write our K, products over reactants. And in this case, our reactants are solids, and solids don't appear in the equilibrium constant. So we don't have to write anything. So now that we have that, we want to find K given the concentrations of silver and chlorine. So now we can plug in our numbers. And remember, the K is actually dimensionless, so we don't attach units to it. So we get 0.25. But remember, we have one significant figure only, so our answer rounds up 0.3 molar. That's how you do it right there.